All right, so like I said, we're going to come up with 4 equations for the 4 different pieces of this function right here, okay? And we're going to work from left to right. So this piece right here obviously is a linear function. So what do we need to know to come up with an equation for that? The slope, okay? So the slope of this, just from looking at the graph, is up 2 over 3. So the slope is 2/3. What else do you need to know? The y-intercept, okay? Now you could try to extend this until it crosses the y-axis by going up 2 over 3 again and up 2 over 3 again. But hopefully you'll see that if you did that, you'd end up crossing in some weird in-between place. So we need to use algebra to figure out what that y-intercept is. So how do you want to do that? What, Andrea? Choose a point? Okay. So this point right here is negative 1, 2, 3, 4, 5, 6, 7. So that is negative 7, 2. So what do I do with that, Andrea, now that I have chosen that point? Okay, so you want to do the y equals mx plus b thing? All right, so we're going to take y equals mx plus b, and we're going to plug in 2 for the y. We're going to plug in 2/3 for the m, and we're going to plug in negative 7 for the x plus b, okay? If I multiply this out, what do I get? What's 2/3 times negative 7? Really, you go to the calculator for that?
14 times negative 7.
Yeah. That would be negative 14 over 3.
I was trying to find a decimal point.
Oh, well, you should be able to do that without a calculator also, because 3 goes into negative 14 4 times with a remainder of 2, so that would be negative 4.6 repeated. You know that.
Yeah, I guess.
But let's go ahead and keep this as negative 4 and 2/3. So what's b? 6 and 2/3. So b equals 6 and 2/3. Okay, so that means our equation for that part right there is y equals 2/3 x plus 6 and 2/3, right? Okay, does that make sense? Okay, what range of x values is that the equation for?
Negative 7.
Negative 7 right here to what? Negative 4 right there. So since this is a piecewise function or a multi-part function, we need to say this is the equation over the space negative 7 is less than or equal to x is less than or equal to negative 4. Okay? So that's the equation for this piece, and this is the range over which that works. Okay? So far so good? All right, now let's come up for an equation, come up with an equation for the next piece right here. Okay? This is a semicircle. Well, luckily you know the formula for the equation of a circle. No, that's for the area of a circle, but for the equation of a circle, remember we had x minus the x coordinate of the center squared plus, maybe we should get that going. Let's see. The general equation for a circle is x minus the x coordinate of the center squared plus y minus the y coordinate of the center squared equals the radius squared. Okay? So just like a line has a general equation, y equals mx plus b, circle has a general equation too. Okay? And we've kind of gone through this a little bit before about that. All right, so if we go back to this thing over here, where is the center of this circle, if it was a whole circle? Negative 2.5, comma 4. Okay, what is the radius of that circle if it was a circle? 1.5. 1.5.
It's gonna be smart.
This is going to be sloppy. So that means the equation for that circle, the whole circle, would be what? X plus 2.5 squared, because it's x minus the x coordinate of the center, plus y minus 4 squared equals 1.5 squared. Okay? So again, x minus the x coordinate of the center plus y minus the y coordinate of the center, those things are squared, equals the radius squared. And most of the circles that we've been dealing with, because we have been able to dictate where the x and y axes have gone, we've made the center 0, 0. So we haven't had to mess with this 2.5 and minus 4 thing very much. But those days are over. Okay? All right, now we need to get this to kind of match this right here. This was y equals, right? So I need to get this to be y equals also. So I'm going to take this and I'm going to solve it for y. What do you want to do first? I could FOIL things out, but that's actually going to make things more complicated. Should I just show you?
Yeah.
Okay. I'm going to take and subtract that term first. So I'm going to make it y minus 4 squared equals 1.5 squared is 2.25. So I'm just going to write that as 2.25 instead. Minus x plus 2.5 squared. Okay, so I just brought that thing over to the other side. All right. How can I get rid of this squared? Square rooting both sides. If I square root the left-hand side, I get y minus 4. If I square root this side over here, I get the square root of 2.25 minus x plus 2.5 quantity squared. Okay? And that's when Kenny said this is going to be kind of a little bit of a mess, and he was right. Okay? Now, when you take the square root of a number, you actually get two numbers, right? A plus and a minus. Which piece is this? Is this the plus or is this the minus?
Minus.
This is the minus. How come? Because it's upside down, right? It's the bottom part. This is going to be the plus over here. This is the minus right here. So this should have a negative sign in front of it, okay? And then what's the last thing I need to do to get the y by itself? Add 4. So my equation for the circle is going to be negative square root of 2.25 minus x plus 2.5 squared plus 4. And that's going to be over the interval from what to what? X is what?
Negative 4 to negative 1.
And negative 4 to negative 1. Okay? All right? How are we doing so far? That was the hard part. Okay? That little semicircle, that was the hard part. Right, but now we know how to do it, so it won't be quite so bad. Okay? All right, what's the equation for this little horizontal piece right here? Y equals what?
4.
Y equals 4, because that's a horizontal line right at y equals 4, so I'm just going to put a 4 right there. What interval is that the equation for? Negative 1 to 1, so that would be negative 1 to 1 right there. Okay? And then we have to deal with a semicircle again. Okay? What is the center of this semicircle?
We have a question.
What?
For the circle, the one where it says negative 4, the next one should be less than or equal to.
I was hoping someone would ask that. I was thinking it might be Brandon, but I'll take you. That's fine. Yeah, what he's noticing is here I used less than or equal to, less than or equal to, and here we just did less than. It can't be both. So if this equals negative 4 right here, then this can't be equal to negative 4 also, you know what I'm saying? So I could have actually made this one be just less than negative 4 and this one be less than or equal to, and it would have been fine. I could have made that, you know what I'm saying? I just have to choose. And since they meet at that point, it doesn't matter which function I choose to use for the exact value of -4. But I can't say that x equals -4 is this function and x equals -4 is that function. I have to choose. Okay? Good question. Thanks for asking that. All right, what's the center of that little semicircle there on the right, the last piece of this nightmare? 2.5, comma, 4. Right, so it's going to be the exact same thing as the other circle with two minor and yet important changes. First of all, the square root is going to be positive. Okay. So I'm not going to put that negative out in front. It still has the same radius, so it's going to be 2.5 there minus, but instead of being x plus 2.5, it's going to be x minus 2.5. Plus 4, and that will be over the range from where to where?
Would that be -4?
No, it still ends up being y minus
okay.
4 here and y minus 4 there, so that won't change, okay? So that's over the x range from where to where? 1 is less than x, which is less than or equal to what? 4. Okay? All right, so there is a multi-part function with 4 parts. One part where the x is from -7 to -4, another part where the x's go from -4 to -1, another part -1 to 1, and a final part from 1 to 4. Okay? So we're just coming up with the equations for each one of these little pieces and then putting it all together. Okay? And there is a way you can graph that on your calculator. I can't remember what it is, but you can do it. We could do it just to check our work. I was going to like put it in there and we can see the instead of but you don't like that. Right, okay. All right. All right, so let's, now what we're going to do is we're going to take a function and we're going to graph it, and then we're going to look at the graph and we're going to break it into 2 pieces based on the graph, okay? So find the multi-part function to represent f of x equals 3 plus 2x minus 1, okay? Do you remember what an absolute value function graph looks like? It's a V-shaped graph, right? So what we're going to do is we're going to break that down and have 2 linear graphs instead, okay? One for one side of the V and one for the other side of the V, okay? If you look at the absolute value of 2x minus 1, where does that equal 0? No. So what value of x does that equal? What's that?
0.5.
X equals
Positive or
0.5.
-0.5.
No, just positive 0.5.
Yeah.
Okay. So this is going to equal 0 when x equals, thanks, 1/2. Okay. So what that means is 1/2 is going to be x equals 1/2. Maybe I'll go by halves. X equals 1/2 is going to be the bottom of the V. Does that make sense?
Yeah.
Yeah? Okay. And so what you need to think about for absolute value functions is if I put in a number that is bigger than 1/2, what's going to be true about 2x minus 1?
It'll be positive.
It's going to be positive, right? If I put in a number for x that's bigger than 1/2, then 2x minus 1 will always be positive. What happens when you take the absolute value of a positive number? Nothing. Okay? So what that means is if x is bigger than 1/2, I don't need these absolute value signs anymore. Because it's just going to be positive anyway, so it's not going to change my answer. Does that make sense? Okay? So the first piece of my function I could write as 3 plus 2x minus 1 when x is greater than 1/2. But we would prefer to write that as what? Two x plus 2 just by combining my like terms there. when x is greater than 1/2, okay? All right, what happens when x is less than 1/2? Obviously, the 2x minus 1. And this is going to come out to be negative, okay? So let's say I put in a -4. Let's say x equals -4. That's a number less than 1/2. What do I get under for the absolute value of that? Family? What? If I take and I figure out the absolute value of 2x minus 1 when x equals -4, then what do I get? I would end up getting y equals 9, right? Okay. What if I put in x equals, I don't know, -3, what do I get? Y would equal 7, okay? So what is the slope that I have? So if I thought about this as just a line in and of itself, when my x's went up by 1, what happened to my y's? They were down by 2. So can you see that the slope of that piece of the line would be -2? Okay. What would the y-intercept be? If we play Andrea's little game of going y equals mx plus b, and these are two of my points, which point do you want to choose? -4, 9 or -3, 7, which one? -3, 7, okay. So 7 equals -2 times -3 plus b, so the y-intercept for that would be what? 1. Okay, so when I am looking at only the negative numbers, the equation for my answers would be y equals -2x plus 1. So do you see a relationship between the absolute value of 2x minus 1 and -2x plus 1? I just had to switch them both, right? Because we're dealing with negative numbers now. So my function for that part is going to be, instead of 3 plus 2x minus 1, it's going to be 3 plus what? -2x plus 1. Okay? Which we would also write as, if I combine my like terms, -2x plus 4. And that's for where x is what? What values of x does that work for? Less than 1/2. Okay?
Which one's the worst?
Which one would you like it to be? The top one? No. All right. So now that I have that broken down into two separate pieces, I can graph those two separate pieces. What do we know about this graph right here? Where does it cross the y-axis? 2. What is its slope? 2. 1, 2. So it's going to cross the y-axis right there, and it has a slope of up. Oh, I'm going by almost screwed up there. So this is 1, 2, 3, 4. Okay, so this is up 2 over 1. Maybe I should have gone by 2. It's up 2. Up 2 over 1, okay? But that only happens where x is greater than or equal to 1/2, right? So I'm not going to draw this whole line in there like this. That's a no-no, because that's starting where x equals 0, right? I need to start where x equals 1/2 instead. Does that make sense? I need to scoot this from here. So it starts at x equals 1/2. Okay? Same thing with the other line, -2x plus 4 when x is less than 1/2. Where does that cross the y-axis? That's 4. And what is its slope? -2, so I would go down 2 over 1, which would give me a line like that. but this one I want only where x is less than 1/2, right? So that's going to be the part of the V-shaped curve that's going to go off in this direction, okay? And so that gives me the V-shaped graph that you guys said we were supposed to get from the very beginning. 3 plus 2x minus 1, so it's at 3 because it got moved up 3. It has a slope of 2 because that number right there. So we took this absolute value function right here and rewrote it as two pieces, this one and that one. All right? Yeah? Anthony?
Without finding those two, but we have to find those two, right?
We have to find these two? Yeah. You can graph it without finding those two.
Right.
Yeah. But what we're doing is we're taking, we're trying to find those two, okay? All right, so let's try another one, and hopefully this will be a little bit easier because we did one already. So find the multi-part function to represent this right here. So here's your step-by-step. Where does the stuff in the absolute value equal 0? At x equals -4. Okay? So that's how you're going to divide these two pieces up. You're going to have one piece where x is less than or equal to -4, and you're going to have one piece where x is greater than -4. Okay? That's your dividing line, where the stuff inside the absolute value equals 0. Okay? So let's do the easy one first. So if I am greater than -4, what's true about all of the things inside here? They're positive, so that means I don't need the absolute value symbols anymore, so I can think about them as parentheses instead. So that would be 3 parentheses x plus 4 minus 5. What do you get from that? (3x plus 7). Okay? So where x is greater than -4, our graph is going to look like part of the graph of 3x plus 7. Okay? All right, how about when x is less than or equal to -4? When we did that example before on the previous page, what did I have to do to the x? Make it negative, and what did I have to do to this number right here? Yeah, opposite. So if it was negative, it'd be plus, but this is plus, so it will be negative. So that means I need to rewrite this as 3 times -x minus 4 minus 5, right? What does that simplify to be? -3x. This will be -12 minus 5 is -17. So that's going to be -3x minus 17 when x is less than or equal to 4. Okay? So we have those written down. And you have the, okay. So what that means is our graph, what was the first one? -3x minus 17, and that was where x is what? Less than or equal to -4. Okay, so less than or equal to -4. And then the other one was what? 3x plus 7. And that is where x is what? Greater than -4. So if you graph this, and there's the first piece and there's the second piece. Okay, so those are the two piecewise functions that we made to equal this original absolute value function. Should we graph the original absolute value function just to see how it fits with this? Sure. So the original one was what? 3 absolute value x plus 1. And then plus 4. Oh, plus 4 inside? Minus 5 on the outside? Okay. And what should happen when we graph this?
Line up first.
Should line up perfectly with the other thing. You should be able to see any new graph on the page. Okay? All right? All right, so one more time. If you want to take an absolute value function and you want to break it into two pieces, you have to find out where this stuff inside the absolute value equals 0 first. So in this case, that was -4, okay? On the positive side of that, you just treat this just like you would as a regular x plus 4, okay? On the negative side of that, you change this to be negative and that to be the opposite, and then things will work out for you, okay? Let's not mess with squared ones yet, okay? What's that? Nothing. Okay, so let me give you a few problems to work on. It's been so long since you've had an assignment.
Well, it has a second.
Well, you know.